Good morning, everybody. I'm just going to run through our notes really fast here. They can get a little bit hairy, but let's hope that we can get through them. So we're just looking at a couple theorems today, and they deal with our complex and our irrational numbers. So first, on our complex numbers, it says, if we have a polynomial with real coefficients, and we have this imaginary number, a plus bi, as a zero. So that's saying if we find, like using our quadratic formula, that 2 plus 3i is a zero, then the other zero that we have is the exact same thing, 2 and 3i, but now there's a minus sign between them. So if you remember this term, this is called the conjugate. We had to use them when we were dividing our imaginary numbers. So if we have a guy that has 2 plus something or whatever number plus an imaginary number, we also have the one that's minus. This is the exact same thing on our irrational conjugates theorem. So if we have something and we find that a plus the square root of b is a zero, so let's say 2 plus the square root of 3, what other zero do we automatically have? Well, the exact same things. 2 and the square root of 3 in the same spot. Now just with a minus sign between them. So no matter what, on these types of problems, we have two zeros total. So for example, this says write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and 3 and 2 plus the square root of 5 is zeros. So what are the zeros? What do I tell you the zeros are? Well, 3 is a zero, so 3. I tell you 2 plus the square root of 5 is a zero. But this is a complex number. We have a 2 and a square root of 5. So what else is a zero? Well, the 2 and the square root of 5 in the same spot, but with a minus sign now. So now the question is, how do we write this in factored form? Well, if you remember, when we say it's a zero, we're really saying that this is like x equals 3. We want it to equal 0. So how do we make it equal 0? We would have to subtract our 3. So we would want it to read like x minus 3. So just take all of these guys here and switch the first sign. So x minus 3, x minus, and I'll put this in parentheses, 2 plus the square root of 5. And then down here, x minus 2 minus the square root of 5. And this is the part that can get a little annoying. We need to expand. We need to FOIL this out. And so I'm going to say FOIL our square roots first. So I'll take this x minus 2 plus square root of 5 times our x minus 2 minus square root of 5. And the first thing I'll do is I'm going to distribute this negative through to both of them. So we end up getting a minus 2 and a minus square root of 5 on our first guy. And our second guy, if I distribute, I'll get minus 2 and plus square root of 5. So we really have 3 terms. So when I distribute, I'll take x times x to get x to the second, x times negative 2 to get minus 2x, and x times the square root of 5 to get plus square root of 5. Sorry, I wrote that really wrong. Plus square root 5x. I'll do it for the middle terms. So I'll get minus 2x plus 4, negative 2 times negative 2, and then minus 2 square root of 5. And then I'll do this for our last term. I get minus square root 5x minus 2, negative times negative gives me plus. So plus 2 square root of 5, and then negative square root 5 times positive square root 5 would give me, the square roots actually just go away, so I just have 5 left. So I just have minus 5. Now I'm going to look to combine like terms. So where are some like terms? Well, this x squared doesn't have any like terms, so he's fine. I see a minus 2x right here and a minus 2x right here. So far we've come up with x squared. Negative 2x minus 2x is negative 4x. Over here, I see a plus square root 5x and a minus square root 5x. So those just go away. Over here, I see a minus 2 square root 5 and a plus 2 square root 5. So those just go away. And then what's left? I still have plus 4 minus 5. So 4 minus 5 gives me negative 1. So it gets a little hairy at first, but we know what to do. Now that was just our imaginary part, so we still have to FOIL it with this x minus 3. So we'll do that real fast. So x squared times x. Let me give myself a little more space over here. X squared times x gives me x to the third. X squared times negative 3 gives me negative 3x squared. Negative 4x times x gives me minus 4x squared. Negative 4x times negative 3 gives me plus 12x. Then negative 1 times x gives me minus x. And negative 1 times negative 3 gives me plus 3. So like terms, well, this x to the third is all by himself. I have negative 3x squared minus 4x squared, so negative 7x squared. For here I have plus 12x minus x, so plus 11x. And then this plus 3 is all by himself, so plus 3. So that's our answer. It's just a bunch of FOIL today. So like I said, it can get a little hairy when we have our square roots and imaginaries, but we know what to do. We just need to keep everything straight. We won't worry about checking. So it's the same sort of idea down here. We're going to write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and our zeros are 3 and 3 minus I. So if our zeros are 3 and 3 minus I, to write it in factored form, we'd have x minus 3, x minus 3 minus I. What other zero do we have? Well, according to this guy, we also have 3 plus I. So x minus 3 plus I. And we're going to treat this the exact same way. We're going to FOIL the imaginary part first. As you saw above when we FOILed it first, all of those square roots canceled out. So down here, all of our imaginary numbers should cancel out. So 3 minus I and x times 3 plus I. So once again, I'll distribute my negative through first to get x minus 3 plus I on our first guy and x minus 3 minus I on our second guy. Now I'll just FOIL through. So x times x gives me x to the second. X times negative 3 gives me negative 3x. X times negative I gives me minus ix. Negative 3 times x gives me negative 3x. Negative 3 times negative 3 gives me plus 9. Negative 3 times negative I gives me plus 3i. I times x gives me plus ix. I times negative 3 gives me minus 3i. And I times negative I, remember that gives us negative I squared. But what is I squared? That's negative 1. So I get negative 1, which gives me positive 1. So now we'll just go through and see our like terms again. So our x squared, he's all alone on his own island. I see a minus 3x right here and a minus 3x right here. So I get minus 6x. I see a minus ix and a plus ix. So those go away. So any terms with our i's we need to look to get rid of because we have the same thing. I see plus 3i and minus 3i. those go away. And then I see 9 plus 1 to give me plus 10. So anything that has an I should cancel out. That's why we're going to do our i's first. But now we still have to do our multiply it with our x minus 3. So we'll just FOIL this guy out again. So x squared times x gives me x to the third. X squared times negative 3 gives me minus 3x squared. Negative 6x times x gives me minus 6x squared. Negative 6x times negative 3 gives me plus 18x. 10 times x gives me plus 10x. And 10 times negative 3 gives me minus 30. So when I combine like terms, I have this x to the third. Minus 3x squared minus 6x squared gives me minus 9x squared. 18x plus 10x gives me 28x. And then, of course, this minus 30 is all alone at the end. So I'll just put minus 30. So like I said, it can get slightly confusing at the start. If you need help, please Canvas message me. I hope you all have a wonderful day. Maybe go play out in the snow a little bit if you're feeling brave. But again, if you have any questions, please contact me. Have a great day.